Hi everyone, my name is Shyam Sharma. I'm currently pursuing my master's in computer applications from IIT Patna, and the track that I chose for the Google AI Partner Catalyst Hackathon is Datadog. Now, over the last year, I have built and deployed multiple LLM agents in production, and one pattern kept repeating. When LLMs fail, we don't notice until users complain, and by then the damage is already done. Sentinel-G exists to solve that exact problem. Most teams think LLM reliability is about latency or uptime. It's not. The real problem is that LLM failures are silent, expensive, and invisible. A hallucination doesn't crash a server, it quietly destroys trust, conversions, and revenue. And observability tools today don't see it. Tools like Datadog, Prometheus, or New Relic are excellent at infrastructure monitoring. But LLMs don't like CPUs or memory. They fail in confidence, semantic consistency, token behavior, and user impact. And those signals simply aren't modeled today. To solve that problem, Sentinel-G was built. It entirely sits and it's based out of Datadog. It is a deterministic LLM reliability control plane. It sits alongside Gemini or any vertex powered application, continuously observing LLM behavior in real time without guessing, without training data, and without black box ML. Now, let me show you the system in action. Right now, as you all can see, the application is healthy, the confidence score is stable, latency is within baseline, and diversity is intact. Now, I will intentionally trigger a hallucination. Notice what happens. Sentinel-G doesn't just say something is wrong, it classifies the failure as hallucination risk, explains why it happened, and immediately quantifies the business impact. I'll show you the backend logs for the same, which sits on the Datadog pipeline as well. As you all can see here, the Datadog event is created and the ID here is visible as well. Now back to our presentation, I want to draw your attention to the business impact dashboard. This is the part most systems completely miss. Sentinel-G translates technical degradation into currency. In this case, one incident represents $122,638 at risk in 24 hours, broken down into conversion loss, refund costs, and support overhead. That's a signal executives act on instantly. Now, we don't just stop at that, but we are also planning on introducing autonomous remediation, and we have made strides in that as well. For example, when a failure is detected, Sentinel-G automatically emits structured events into Datadog with full context, metrics, and recommended actions. I can now apply a recovery action, and I also have different options which are based on success rate, which is based on classification and regression at the same time. Let's suppose I want to apply fix 1. I'll just click on apply fix, and boom, it will resolve the incident. Here, the Datadog event was created, LLM recovery applied, fallback to Claude 3.05 Sonnet for 30 minutes. The system executes the recovery, confidence is restored, latency normalizes, and the incident is resolved, all while being fully observable. Similarly, we can also trigger a latency spike, apply a fix, trigger a cost anomaly, apply effects again, and this all happens within seconds. Now, before wrapping up my presentation, I'd like to draw your attention to the architecture diagram of Sentinel-G. This is the architecture diagram of Sentinel-G. It is divided into four different layers, which are the client layer, the application layer, the Sentinel-G backend, observability integration. Now, the backend is the actual brain. It consists of the telemetry collector, the deterministic failure classifier, risk attribution engine, and the recovery recommendation engine. And all this data is connected into a recovery execution endpoint, which is then integrated through Datadog Events API, Datadog metrics, and logs. I built Sentinel-G using deterministic rules instead of probabilistic ML because reliability systems must be explainable, testable, and trusted. This works on day one, requires no training data, and produces zero false positives. LLMs are becoming core infrastructure, but without reliability, they are liabilities. Sentinel-G turns LLM into systems we can actually trust and